Okay, let's choose another example. Let's choose this equation from optics, which is 1 divided by the object distance plus 1 divided by the image distance equals 1 divided by the focal length. Again, you don't actually need to know what any of this means. You just need to know what it's asking you to do. So the variables it's interested in are the image distance and the object distance. So let's write this down. 1 divided by object distance plus 1 divided by image distance equals 1 over the focal length. And it wants object distance, it wants image distance. So we've got to put these two things on either side of the equal sign. So let's do that simply. 1 divided by dO equals minus 1 over di plus 1 over f. And now we have an equation of the form y equals mx plus c. So y is the variable on the y-axis, so we can take this down here and draw this just to give you an illustration. So the y-axis, this one up here, will be 1 over d0, and the x-axis will be 1 over di. And there will be some intercepts, which will be 1 over f, and there is a gradient, because we have a negative sign here. So, what does this actually look like? The gradient will be minus 1, so presumably it sort of looks something like this. And it will have a y-intercept, and that y-intercept will be 1 divided by f. And as we say, the gradient will be minus 1. So it will give us a linear equation. It will give us a linear equation with a gradient down here. It will give us a y-intercept of 1 over f, and it's actually f that it's interested in. So if the y-intercept equals 1 over f, therefore f equals whatever the 1 divided by the y-intercept. So that's how you could draw the graph and then interpret the graph to give you a value for the focal length of your lens.